let's take a closer look at some of the challenges teams face in the traditional machine learning lifecycle. If we summarize the flow of this lifecycle at a high level, an ML project generally has two main phases. The first is the research and development phase, which includes data acquisition, data processing, model building, training, and validation. This is mostly a phase of experimentation, led by data scientists and supported by data engineers when needed. The second part is the operations phase, where the real implementation occurs and business value is generated. Here, the operations team takes that experimental model from data scientists, makes it production-ready, and then deploys it. Now, while this may sound straightforward, the reality is often far from easy, and this complexity is a major reason why 80% of models never make it to production and remain only as proofs of concept, or POCs. So why is this the case? Let's break it down step by step. Now, ideally, data scientists should be spending all their time writing algorithms, building models, and training them. But in reality, 30 to 40% of their time is taken up by other activities. Why is that? And what exactly are these other activities? Machine learning is often approached from the perspective of individual scientific experiments, and this means data scientists frequently work in isolation. Once the project requirements are defined and data is cleaned and pre-processed, data scientists typically work on their own local machines, often a laptop or desktop, to create and train models. They might use a Jupyter notebook to test different model versions, perform various iterations, and refine their approach until they find an optimal version. But this version exists only locally and is primarily understood by the data scientist who created it. Most data scientists, however, aren't developers by trade. They specialize in creating effective algorithms, working with statistics, and building neural networks. This means their code is often highly effective for experimentation, but may not be built to be robust, scalable, or manageable for production use. When it's time to hand off the model to the next stage, this work is often shared with the operations team by email, USB, or shared drives. And yes, this is common, not due to a lack of protocol, but rather because there's often no systemized approach. The operations team receives the notebook and has the task of training the model on larger datasets and integrating it into production applications. However, here's where things get tricky. Both teams use different technical languages, tools, and methods. As a result, the operations team might struggle to understand the code, dependencies, and parameters that make the model run effectively. This creates a knowledge gap, leading to technical friction that slows down the deployment process. In some cases, the entire model code may need to be rewritten in a different programming language to make it production-ready. This process is repetitive and error-prone, creating what's often called a virtual wall between data scientists and the operations team. On one side of this wall, data scientists work in their own silos, creating models in Jupyter notebooks, and then throwing them over the wall to operations. On the other side, software engineers try to make sense of the model code and prepare it for production. Clearly, this wall needs to be dismantled for smoother project operations. One solution could be having the data scientist directly support the operations team, but in reality, this often leads to endless back-and-forth emails, meetings, and clarifications. Data scientists, who ideally should focus on modeling, often end up spending 40 to 50% of their time supporting deployment processes. This inefficiency is one of the main reasons why 80% of models don't make it to production.